Good morning, boys and girls. So what I want us to do is, if you do not have your benchmark book out, please get it out and turn to page 22, Updating Archaeology. So this is going to be the last story in our unit. And so what I'm going to have us do is we're going to go ahead and read it and annotate it today. And you're also going to be doing some comprehension questions. So if those have not been passed out to you, go ahead and pass out the comprehension questions, and then we will get started. Make sure that you choose a color or your pencil that you want to use today to annotate with, so that will change as we go throughout these lessons so that we can kind of see what our annotations are, okay? So updating archaeology. This actually goes a lot with what we're talking about when in social studies. We've done the first unit on the Stone Age where we did talk about archaeology, and we've also done the unit and we're now in Egypt, and there's a little bit about King Tut that's in this one as well. So let's first just underline this word archaeology. We know from Greek and Latin root word parts that ology means the study of. And so hopefully then here as we go, we will learn a little bit more about that. So let's go ahead and read. Archaeology is a scientific study of past human life through the recovery and analysis of material relics and environmental data. So I'm going to underline this because it's pretty important. So it is the study of past human life by looking at things like artifacts. That's what relics kind of means. And the recovery and the analysis. So they find it and then they analyze it, okay? Or they look deeper at it, okay? Archaeologists locate and study fossils, artifacts, architecture, as well as ecofacts such as plant seeds or animal bones. Through the centuries, many treasured artifacts have been lost to natural forces, so that's like nature, or stolen by treasure hunters. So they've been lost or they've been stolen. Grave robbers have raided ancient tombs for gold and jewelry and have destroyed valuable parts of burial sites and even mummified bodies. Okay, so if you have not, you can go ahead and pause the video here and make sure you've answered number 1. So on your comprehension questions, and then if things move too fast, you will have time at the end to finish these questions. Okay, so pause the video now and then come back to me when you finish number 1. All right, let's read paragraph number 3. One of the most significant archaeological finds, however, was discovered virtually untouched, meaning not really touched at all. Let me make sure you can see this. Virtually untouched in Egypt when Howard Carter, I want you to underline this man's name, he is a British archaeologist, unearthed the tomb of King Tutankhamun in 1922. So this is in Egypt. This is one of the kings that I was writing about, and then this is the same King Tut that we did our CSI on, okay? Although evidence suggested the tomb had been robbed and resealed earlier in history, Carter found the intact mummy, so that means like not broken or disturbed, of the young Tut, an ancient ruler of Egypt, along with many priceless treasures. These amazing relics continue to tour museums and draw crowds today. So it tells me that they are in museums now. Okay, so they called this find of King Tut a significant archaeological find. I want to know, why was it considered a significant archaeological find? What made it that? So go ahead and do number 2 now, okay? All right, and then here we have this little sidebar. Archaeology is a cross-disciplinary practice that draws on the sciences and the humanities. In their work, archaeologists use knowledge of geology, chemistry, biology, physics, and paleosciences, as well as anthropology, history, art history, linguistics, classics, and geography. So these right here are sciences, and these down here are humanities. Okay? All right, next page, paragraph 4. It's kind of long. Okay, if looking up here, this is Howard Carter looking at King Tut's tomb. Scientists have adapted the latest technology to continue. They've adapted the latest technology to continue studying the artifacts and mummy discovered by Carter. So they adapted it or changed it so that they could study everything that he found. The technology used to conduct excavations, these are like digs, has also improved dramatically since Carter's time. For hundreds of years, scientists would map an excavation site and then use shovels and trowels to dig and screens to sift through soil. So this is what they did first. This is how it was at the beginning. Okay, this is how it was at first. This is before they've updated the technology. Remember, this is called updating archaeology. These methods were slow, so this is the problem, and tedious, and they could damage artifacts. So this is like the problem. And notice that I am not just underlining and not making any notes about it. Okay. According to an Egyptologist, so someone who studies Egypt, from the University of Pennsylvania, cited in National Geographic News, Carter might have handled the physical evidence from his dig more carefully if technologies we have today, such as MRIs, CT scans, and DNA studies, have been available then. So they're saying he may have done it more carefully if they had been available. These look on the inside. Okay. Now, archaeologists use high-tech instruments and advanced methods to preserve sites and artifacts. It means like to save them. They find underground sites using radar and laser imaging equipment. They analyze objects using laser scanners and X-ray guns. When they're with their cutting-edge gadgets, today's archaeologists are more like characters from a science fiction novel, almost like kind of like something that you can make up in fiction. As English archaeologist Ellery Fram told the website Live Science in a 2013 interview, I go out and do archaeology with a ray gun. It doesn't get more sci-fi than that. And sci-fi is science fiction. So I want to know, number 3, why are they like characters from a science fiction novel? When you've answered that, you can go ahead and turn the page and join me on page 24. Okay, the science of archaeology is where we're at. So, the first known archaeological dig was recorded in 559 to 539 BCE. Remember, BCE is before the Common Era, okay? Remember, it's like a timeline, so this would be before the 0 mark, okay? King Nabonidus of Babylon searched for old temples and buildings in his kingdom in order to restore them. So that's why he was searching for, that's why he did the dig. He succeeded in finding a building foundation that dated between 2254 and 2218 BCE. Over the next 2,000 years, people's fascinations with the past waxed and waned. So that means it changed. And it would be interesting and then not interesting. Okay? Until the 1800s, when major breakthroughs in science and technology helped foster a renewed study of the past. So they had breakthroughs in science and technology, and that made people want to study more. Okay? So I'm going to say this is why they studied. The first major step in establishing archaeology as a science came around 1816 CE, so that's the Common Era, after 0, when Danish archaeologist Christian Jørgensen Thomsen devised the 3-age system. So this man created this 3-age system to classify artifacts according to the stages of technological development in prehistoric cultures. He established 3 periods: the Stone Age, the Bronze Age, and the Iron Age. We have studied the Stone Age, and we know that the Stone Age was called the Stone Age because their tools were made of stone. So we can assume with the Bronze Age, it was made of bronze, and the Iron Age, things were made of iron. Each based on the predominant material used at the time to produce goods. That's like the predominant kind of means like the main one. Before this, there was no systematic way for museums to classify different objects. So I want you to answer number 4. Why did Thomsen create the 3-age system? And then join me again in paragraph 8. Okay, paragraph 8. There are going to be some words in paragraph 8 that we're going to talk about a little bit today, but we're going to come back and visit them in a later lesson too, okay? Next, in 1813, Charles Lyell proposed the principle of uniformitarianism. So I want you to circle this word, uniformitarianism. Based on the established law of superposition. So look, 2 words are uniformitarianism and the law of superposition. The law of superposition says that older rock layers lie below younger rock layers. Lyell reasoned that artifacts of older human societies would be found in the older rock layers. So they're saying if it's older, it's down at the bottom. Okay, that's kind of a little bit of logic too. This idea helped archaeologists estimate the ages of artifacts found at different levels. Then in the 1860s, Giuseppe Fiorelli excavated the ancient Roman city of Pompeii, which had been buried by a volcano in 79 CE. Okay, so he excavated it, he dug it out. According to Encyclopedia Britannica, Forielli establishes a meticulous method of excavating layers. So meticulous means like a very detailed, right? Some people might say I'm a little bit meticulous about the way I run my classroom, and I am, because I have a very detailed way that we do it, okay? Preserving much of the Pompeii site intact. At each layer, Forielli made observations and recorded details of his finds. His work influenced modern-day archaeological studies and methods. So the way he did things kind of changed the way that they did a little bit of archaeology. All right. Number 10, or paragraph 10. Until that point in archaeological science, most findings have been documented by artists' drawings. They had been doing their drawings. In 1873, Augustus and Alice Lepon-Leon were among the first archaeologists to use photography to document the discoveries during their uncovering of Mayan sites in South America. So they took pictures instead. Prior to that, they were drawing things. Now, here in the late 1800s, they started taking pictures, which was saving them time and saving them resources and giving them a more accurate depiction of what happened. Beginning in 1898, archaeologists at several sites started using x-rays to examine mummies. So they started using x-rays to examine mummies. And we know that because we saw what happened with King Tut, those x-rays that we looked at. That's part of this. That's why I'm loving that these two are paired together. We've just kind of done some of this work so we can kind of understand exactly what they've been doing. This technique allowed scientists to view the mummy's interior, their inside, without performing an autopsy or cutting it open. Okay? That's like what an autopsy is. The new technology helped preserve the mummies, so save the mummy, since it would not have to be unwrapped and exposed to air or moisture, which could further damage the remains. So it shows how helpful it all is. Okay? So you see, I'm not just underlining and not making notes. We're going to come back through and underline for some other things later. All right. So then let's continue on page, let's see. Yeah, we're on the next page. I forgot that we had not. Oh, there it is. Okay. The use of X-ray technology continued to advance through the 20th century. In 1960, Edward Hall, a leader in the field of archaeometry or archaeological science, so that's what this is, used X-ray fluorescence, XRF, to analyze the composition, like what made up, of ancient Roman coins. This technique identifies certain elements and objects without damaging the samples. Later, computed tomography or CT scanners improved on X-ray technology, producing 3D images or artifacts and reconstruction models of objects. Archaeologists now use portable XRF guns to analyze samples in the field. The 20th century also brought two of the greatest technological advances to the field of archaeology. The first is radiocarbon dating, and the second is remote imaging technology. This is in the 1900s. In 1949, the field of archaeology was revolutionized when chemist Willard Libby proposed a new way to determine the age of fossils and artifacts using radiocarbon dating. So he has found a new way to age everything using this radiocarbon dating. Libby discovered that radioactive carbon, that's an element, okay, present in all living things. I'm going to move this over a little bit. Present in all living things, begins to decay at a predictable rate at the time of death. So this radioactive carbon begins to decay at a predictable rate at the time of death. Thus, the amount of decay in the radioactive carbon of fossils and other ancient life forms could help scientists determine their age. So seeing how much radioactive carbon is left could tell us how old it is, okay? The ability to date findings with accuracy changed historians and scientists' views of the world's past. Okay, so they had not been able to really date things with accuracy before. It changed the way that they viewed things. That would be a huge thing if you're studying history. Okay. The accuracy. Let's see. So that's number 5. You can pause it and then come back and join me for paragraph 15. The accuracy of scanning potential dig sites also improved. In the 1950s, archaeologists first began using instruments called magnetometers to measure magnetic properties below the Earth's surface. Variations in magnetism in the soil, for example, can help identify the presence of objects or artifacts in areas where human activities such as cooking occurred. The results can be recorded and mapped to give an overview of a site for archaeological exploration. Then in the 1960s, LIDAR, which is light detection and ranging, used a combination of light pulses and radar, was attached to planes. So LIDAR was attached to planes and used to scan for possible excavation sites. So this is new. Later in the 1970s, ground-penetrating radar was used to identify structures buried beneath the ground. These technologies let archaeologists work faster and more accurately, allowing them to pinpoint areas to dig and plan their work to avoid destroying valuable artifacts. So this is why it helped. This is the effect, okay? And then down here we have a timeline. So that is number 6, okay? And then we're going to read paragraph 17 and 18. In our digital age, the latest in LiDAR technology is revolutionizing archaeology. That means changing. According to Devin White, senior research scientist at Oak Ridge National Laboratory, many archaeologists put the impact of geospatial technology, so understanding the geography in the space, which would be LiDAR, on par with radiocarbon dating. So they're both of like equal importance. So you have radiocarbon dating, which gives us date, and LiDAR, which helps us understand where to dig, and they're both super important. In 2010, the technology helped archaeologists remap the lost Mayan city of Caracol in Belize, saving scientists years of work. Archaeologists have been mapping the city for 25 years, says journalist Douglas Presslin, and for 5 days, they flew this LiDAR machine over the city of Caracol, and they found that the archaeologists had missed 90% of what was there. They have been looking at this for 25 years. To give you perspective, I am 29. I was 4 when they would have started. Okay, so this is a long time, almost my whole life. And they missed 90%. They only got 10 of it. Okay, 10 out of 100 is how much they found. That's not a lot in 25 years. And they found with this, after 5 days, they missed 90%. And in 5 days, they were able to find more. That's how important this technology is. Currently, space archaeologists can use LiDAR, GPS, global positioning satellites, and other geospatial satellite data to survey and map sites beneath the Earth's surface from thousands of miles away. This makes remote sensing especially useful for areas too dangerous to dig, for physical exploration or traditional digs. So the same way like with robot cops, it made it easier and made it safer for humans, but we could still do what we needed to do. For example, Jason an archaeologist at Harvard University, is using this technology to survey previously undiscovered sites in Iraq, where he found what he calls the richest archaeological landscape in the Middle East. So they used this technology and they looked at previously undiscovered sites in Iraq. Okay. So, how and why. Okay. And this is number 7. So you should have number 7 now. And then let's turn it over and we're going to do 19 and 20. Okay. Advances in technology continue to improve archaeologists' understanding of the past. Yes, we see that. Okay. Devices like X-ray guns and full-body CT scanners allow scientists to study priceless artifacts without damaging or destroying them. So now I kind of see they're recapping for me. This is the conclusion. Ground-penetrating radar, magnetometers, and satellite-based LiDAR help archaeologists find ancient sites that might otherwise be lost to history. 3-dimensional scanners and advanced cameras allow technicians to recreate objects on the screen. Technology has allowed archaeologists to save time and money while conducting excavations. They can solve mysteries about artifacts and ancient buildings in minutes instead of weeks and months. Advances in chemistry, laser, and digital technology are helping them piece together the mysteries of the past, one fossil at a time. And this is their interesting last sentence. Okay? So then that is number 8. When you are done with all of those, you may turn it in and we will revisit this text again on Monday. All right, boys and girls, I will talk to you soon. Bye.